Hello friends, in today's video we're going to be tackling how to find the domain of a function. Now when I see those words, find the domain of a function, I think about the things listed here. Number one, I think about things I cannot do in math. Then I look and see, does the function contain those things? And then finally, if it does contain those things, what does that allow me to do? What can I do? So what do I mean by that? Well, what's the thing you can't do in math? Well, one thing you can't do in math is you can't divide by 0. Okay, so that means that if your function contains a division in it where there's variables and you might divide by 0, then we have to be on our toes. So if I see a function that has a denominator in it and it really doesn't matter what's on top, I really just care about I'm dividing by something. Now if you're dividing by something, what does that allow you to do? Well, it allows you to say that the bottom is not equal to 0. So let's try that again. What's another thing that you can't do in math? Well, we know that we can't take a square root of a negative, and that's more generally, you can't take an even root, so a fourth root or a sixth root or a square root of negatives. Okay, now remember that cube roots are fine, odd roots are fine, you can do negatives underneath those, but if I see a function that has a square root or a fourth root, then whatever's underneath it, I want to make sure is greater than or equal to 0. I want to make sure it's not negative. Okay, and that's again how domain works in general. Okay, so are there any other things that we can't do in math? Well, the third thing that we generally can't do in math is we can't take a logarithm of negative or 0. Okay, so that means that if our function has a logarithm in it, it doesn't really matter what the base is, I really just care about what's going inside there. I need to make sure what's inside there is strictly greater than 0. It can't be negative and it can't be 0, so that means that it has to be positive. So are there any other things that we can't do in math? Well, in algebra, typically this is it. Okay, now you might see some other things when you get to trig, specifically with inverse trig functions, but those will be defined explicitly in those classes. So with that being said, let's dive into some actual examples of how to apply these concepts. All right, so in this problem, we're going to find the domain of f of x is equal to x squared plus 4x all over 2x minus 3. And again, when I'm finding the domain, I want to think about things I can't do. So for example, I can't take the square of a negative, but there are no square roots here, so I really don't have to worry about that. I can't divide by 0, so that means that I need to make sure that the bottom here is not equal to 0. And again, what that allows me to do is write the equation 2x minus 3 is not equal to 0. Now solving this is basically the same as solving 2x minus 3 is equal to 0. We just write not equal to the whole time. So we're just going to isolate our 2x by adding 3 over to the other side. So 2x is not equal to 3. And then we divide by 2, so x is not equal to 3 halves. Now this might be an acceptable answer, but if it says put in interval notation, remember interval notation, we can just draw a number line, square off or dot out 3 halves, and then figure out what does actually work. Well, over here works, and to the right of 3 halves works. So our first interval is negative infinity to 3 halves. And remember, we use parentheses when we don't include the point, and we don't want to include 3 halves. And then we also have 3 halves to infinity on the right side. So we have negative infinity, comma 3 halves, and then 3 halves, comma infinity, with parentheses everywhere. And remember, we do a little union sign in between these two intervals. Let's take a look at another one. So here we're going to find the domain of f of x is equal to the square root of 3 minus 7x plus the cube root of x. So again, here I want to think about things I can't do. Well, again, I can't divide by 0, but there are no divisions in this problem, so I don't have to worry about that. And now I can't take the square root or an even root of a negative. So I really need to worry about this square root because it's an even root, but I really don't need to worry about the cube root because you can take cube roots of negatives. So again, what does that allow me to do? Well, it allows you to take that 3 minus 7x and set it not negative, but greater than or equal to 0. All right, and now we just need to solve this inequality. So here we can just subtract 3 from both sides. We have negative 7x is greater than or equal to negative 3. And then we can divide both sides by negative 7. Remember, when you divide an inequality by a negative, you're going to flip the inequality. So you're going to get x is less than or equal to 3/7. Again, this might be acceptable answer, but if it does say interval notation, a good way to go interval notation is to just draw a number line. And we're just going to put 3/7 on there because that's what it's talking about in this problem. And then we can just shade the portion of the number line that corresponds to x being less than 3/7. So over here, okay. And then that interval has two endpoints. On the left, it's negative infinity because it just goes on and on and on. And on the right, it's 3/7. Okay. Now remember, you can never reach infinity, so I have a parenthesis there. But I want to say less than or equal to 3/7, so I want to use a bracket around 3/7. So we have negative infinity to 3/7 with a parenthesis on negative infinity and a bracket on 3/7. All right, let's take a look at another one. Here we're going to find the domain of f of x is equal to the natural log of 5x plus 4 plus 1 over x minus 2. Again, I want to look for things that I can't do in math. So I can't divide by 0, so if I see this division 1 over x minus 2, I need to worry about that. I need to say that that can't be equal to 0. And number 2, I see this logarithm, and then I need to worry about the stuff inside of it. It can't be less than 0, and it also can't be equal to 0. So what does that allow me to say? Well, it allows me to say that x minus 2, again, cannot be equal to 0. Okay? And it allows me to say that 5x plus 4 is strictly greater than 0. Again, it can't be negative, it can't be 0, so it has to be greater than 0. And again, it's both of these things have to occur. It's an and between these two things, so I need to solve these simultaneously. So I have x minus 2 is not equal to 0. Well, that's pretty easy to solve. You might have already solved it in your head. X can't be equal to 2. So that's one portion of our domain. And then another thing is 5x plus 4 has to be greater than 0. So I can subtract 4 from both sides, get 5x is greater than negative 4, or x is greater than negative 4/5. And again, this is an and between these two statements. So we could write it like this: x is not equal to 2, and x is greater than negative 4/5. How about interval notation? Well, interval notation is we would have negative 4/5. Okay, as one point we'd want on that number line. We have x is not equal to 2 as a point we want to kind of circle out of the number line. And then we want to think about what does that allow us? Well, it can be greater than negative 4/5, so it can be all the numbers to the right of negative 4/5. But then we have this whole at 2. So we're getting separated into two separate intervals. Number 1, negative 4/5 up to 2. We don't include 2, so we use that parenthesis. And then our second portion of that interval is 2, and then it just goes on and on forever, so it goes out to positive infinity or just infinity. So we have negative 4/5 to 2, and then union that with 2 to infinity. All right, and let's look at one more. We have find the domain of f of x is equal to 1 over the square root of 5x plus 1. So again, I see the words find the domain, and I want to think about things I can't do. Well, I see the division bar, so I need to make sure that the stuff underneath the division bar are not equal to 0. And then I also see this root, so I need to make sure that the stuff underneath the root is not negative. So I combine those facts together and I get 5x plus 1 has to be not negative, or in other words, it has to be greater than or equal to 0. And I need to make sure that the square root, or the thing that I'm dividing by, is not equal to 0. So I need to make sure the square root of 5x plus 1 is not equal to 0. Well, in order for a square root to be equal to 0, that would mean that the stuff underneath it has to be not equal to 0. Okay, so I get 5x plus 1 is not equal to 0. And again, it's a combination of these two facts. And if you combine these two facts together, 5x plus 1 is greater than or equal to 0, and 5x plus 1 is not equal to 0, that basically just gets rid of this or equal to. So we have 5x plus 1 is strictly greater than 0. Okay, so we can solve this the same way we did before, just by isolation. 5x is greater than negative 1, or x is greater than negative 1/5. And as always, please take a moment to like this video and subscribe to my channel.